You see the screenshots. Social media explodes. Massive comet hurtling toward Earth. Alien reconnaissance probe. Military mobilization to intercept. The headlines scream collision course. The posts rack up millions of views. September 29th, 2025, the New York Post runs the story that changes everything. Massive comet, larger than expected. Could be alien tech, scientist says. It could change everything for us. Within hours, fabricated quotes attributed to physicist Michio Kaku flood the internet. It might be an alien probe sent to Earth, the Posts claim, to conduct a reconnaissance mission, possibly with hostile intent. 290,000 views, dozens of panicked comments. Except none of it is real. If you value documented astronomical history and verified space science like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from NASA's official 3I Atlas observational data published July through October 2025, the European Space Agency's Near-Earth Object Coordination Center findings from July 25th, 2025, and peer-reviewed. Spectroscopic analysis published in the Astrophysical Journal Letters on August 25th, 2025, by Martin Cordner and 12 co-authors from NASA Goddard Space Flight Center. These aren't secondhand summaries. These are primary observation reports from the James Webb Space Telescope and Hubble Space Telescope, capturing real-time data. Now back to the information. 137,000 miles per hour when first spotted. The designation comes through the International Astronomical Union's Minor Planet Center within hours. 3I Atlas, the third confirmed interstellar object ever observed entering our solar system. The hyperbolic trajectory proves it. When you trace the orbit backward, it originates from outside our solar system entirely, coming from the direction of Sagittarius, from somewhere near the galactic center. 210,000 kilometers per hour by August observations. The fastest interstellar visitor on record, faster than Oumuamua in 2017, faster than Borisov in 2019. And here's where panic takes root. Every new object gets listed until the orbit is confirmed. But people see near-Earth object and stop reading. Social media does what social media does. The conspiracy engine fires up. Some accounts claim the comet is actually a spacecraft. Others insist governments are hiding impact projections. Posts reference supposed military movements, international coordination to deflect the threat, screenshots of edited television interviews, all fabricated, all viral. 270 million kilometers away, more than 700 times the distance between Earth and the Moon. 1.8 astronomical units to be exact. For context, 1 astronomical unit is the distance from Earth to the Sun. So 3. Atlas passed at nearly twice the Earth-Sun distance, making any collision scenario physically impossible. The European Space Agency confirms it. The orbit is stable. The trajectory is known. The comet will reach perihelion, its closest point to the Sun, on October 30th, 2025. Even then, it stays 210 million kilometers from the Sun, just inside Mars' orbit, never anywhere near Earth. One scientist keeps pushing the alien hypothesis. Avi Loeb, former chairman of Harvard's Department of Astronomy, head of the Galileo project. He's done this before. With Oumuamua in 2017, he suggested it could be an alien light sail. Now 3I Atlas. July 3rd, he's quoted in the Daily Mail mentioning spacecraft possibilities. By July 18th, he's publishing preprint papers. Is the interstellar object 3I Atlas alien technology? The title asks. The paper lists anomalies. The orbital plane aligns within 5 degrees of Earth's ecliptic. The comet will pass close to Venus, Mars, and Jupiter. It's heading to solar conjunction, passing behind the Sun from Earth's view right at perihelion. The optimal time for a reverse Oberth maneuver, a gravity assist to change trajectory, hidden from Earth-based telescopes. The paper invokes the dark forest hypothesis. Any advanced civilization might preemptively strike to eliminate threats. The consequences, should the hypothesis turn out to be correct, could potentially be dire for humanity, Loeb writes. Defensive measures might be required, though these might prove futile. 3. Atlas sits 277 million miles from Earth. The image shows a teardrop-shaped cocoon of dust coming off a solid, icy nucleus. Classic comet behavior. The coma, the fuzzy atmosphere surrounding the nucleus, measures between 26,400 by 24,700 kilometers in diameter, about twice Earth's diameter. The nucleus itself, the solid core, remains harder to measure because the coma obscures it. But Hubble's continuing observations through August 20th narrow it down. The diameter is not less than 440 meters, not greater than 5.6 kilometers. Somewhere in that range, most likely under 1 kilometer based on brightness models. August 6th, 2025, the James Webb Space Telescope turns its near-infrared spectrograph on 3I Atlas at 3.32 astronomical units from the Sun, the spectral images span 0.6 to 5.3 micrometers. Infrared wavelengths that reveal molecular fingerprints. What do they find? Carbon dioxide dominates the coma. Water ice present. Water vapor detected. Carbon monoxide gas. Carbonyl sulfide tentatively identified. Dust grains. The carbon dioxide to water mixing ratio measures 7.6 plus or minus 0.3, among the highest ever observed in any comet. 4.5 sigma above the trend for long period and Jupiter family comets. This tells you something profound. The comet's nucleus is intrinsically carbon dioxide rich. It likely formed far from its parent star, beyond the carbon dioxide ice line, where temperatures stay cold enough for carbon dioxide to freeze solid. The composition matches objects from the outer reaches of planetary systems. Not alien technology, ancient ice from another star's planetary disk. 14 plus or minus 0.9 kilograms of carbon monoxide per second, 0.43 plus or minus 0.09 kilograms of carbonyl sulfide per second. These are the sublimation rates. Ice turning to gas as solar radiation heats the nucleus, exactly what comets do. The enhanced outgassing occurs in the sunward direction. Standard cometary behavior driven by solar heating. The carbon dioxide gas coma extends at least 348,000 kilometers in radius, visible only in near infrared. From Earth, the angular diameter measures about 2 arcseconds for the brightest part, 10 arcseconds for the full extent. As 3, I Atlas approaches the Sun, activity increases. Pre-discovery observations from the Vera Rubin Observatory show the coma growing from 13,040 kilometers on June 21st to 18,760 kilometers on July 2nd. The Neil Gehrels Swift Observatory detects ultraviolet emission from hydroxyl radicals on July 31st and August 1st. Assuming water is the source, they calculate a water production rate of 1.36 plus or minus 0.35 times 10 to the 27th molecules per second at 2.9 astronomical units from the Sun. The Very Large Telescope in Chile captures spectroscopy August 21st, confirms cyanide emission, detects nickel vapor. Both are products of cometary outgassing. Lowell Observatory also detects cyanide. The James Clerk Maxwell Telescope measures hydrogen cyanide production rates, September 7th and 14th. The rate climbs from 1.5 times 10 to the 25th molecules per second to 4.5 times 10 to the 25th molecules per second, 2 kilograms per second. The cyanide coma measures 180,000 kilometers across. Asymmetric. Elongated away from the Sun, a visible dust tail stretches 100,000 kilometers. Tom Statler, NASA's lead scientist for solar system small bodies, addresses Loeb's claims directly in September. It looks like a comet. It does comet things. It very, very strongly resembles, in just about every way, the comets that we know. It has some interesting properties that are a little bit different from our solar system comets, but it behaves like a comet. And so the evidence is overwhelmingly pointing to this object being a natural body. It's a comet. Statler explains, comets react unpredictably to solar radiation. Even solar system comets suddenly brighten when pockets of ice sublimate quickly and drive off large amounts of dust. 3. I Atlas is no exception. It's just the first carbon dioxide-rich interstellar comet we've caught early enough to study properly. First anomaly. The orbital plane aligns within 5 degrees of Earth's ecliptic. Loeb calls this an astounding coincidence, but planetary systems form from flattened disks. Objects ejected from those disks carry low orbital inclinations. Our solar system's ecliptic is tilted 23.4 degrees to the galactic plane, so any object moving through the galaxy has some probability of aligning with our ecliptic. Not a red flag, just geometry. Second anomaly, the size seems extremely large. Loeb initially claimed 20 kilometers diameter based on early brightness estimates. Later observations disprove this. Hubble shows the nucleus is likely under 1 kilometer. The brightness comes from the coma, not the nucleus. Loeb cited the paper showing 2.8 kilometers radius and chose to ignore it. Steve Desch, an astrophysicist at Arizona State University, calls the work sloppy beneath the level of an undergraduate and grades the paper accordingly. The comet passes near Venus, Mars, and Jupiter. Loeb calculates the probability of these close approaches as 0.005% if the entry time is random. But this assumes the solar system is empty space. Planetary orbits are predictable. Objects on hyperbolic trajectories passing through the inner solar system have decent odds of approaching at least one planet. October 3rd, 2025. 3I Atlas passes 30 million kilometers from Mars. The European Space Agency's Mars orbiters, Trace Gas Orbiter and Mars Express, turn their cameras toward it. Trace Gas Orbiter's Cassis instrument captures images. The comet appears as a slightly fuzzy white dot among streaked stars. The imaging system is designed for Mars surface observation at hundreds to thousands of kilometers. Not a dim object 20 million miles away, but it works. The coma is visible, not a smooth metallic surface, not a spacecraft, fuzzy gas and dust. Early observations didn't show strong spectral features. But 3 I-Atlas was 4.5 astronomical units from the Sun at discovery, 670 million kilometers. At that distance, cometary activity is low. As it approaches the Sun, activity ramps up. All the spectroscopy from August onward shows abundant gas emission: carbon dioxide, water, carbon monoxide, cyanide, nickel. Loeb's claim dissolves under actual data. Solar conjunction happens. October 21st, 8 days before perihelion. This could be intentional, Loeb suggests, to avoid detailed observations from Earth-based telescopes when the object is brightest. But orbital mechanics don't care about Earth's viewing angle. 3. I-Atlas entered the solar system months before anyone detected it. Pre-discovery images go back to June 14th. Its trajectory was set long before humans even knew it existed. The conjunction timing is coincidence, not intent. The optimal point for a reverse Oberth maneuver occurs at perihelion. The idea is a spacecraft could burn fuel at perihelion to change velocity efficiently using the sun's gravity well, then use that velocity to reach Earth by November or December 25. Except there's no evidence of non-gravitational acceleration beyond what outgassing produces. Borisov, the second interstellar comet, showed small non-gravitational acceleration from outgassing. Standard comet behavior. 3. I-Atlas shows the same. If it were a spacecraft executing maneuvers, we'd see velocity changes that don't match gas emission patterns. We don't. The heavy dust grains pushed out by internal activity, driven by solar heating, create a stream in the sunward direction. Solar radiation pressure isn't strong enough to blow these large grains backward, so they trail forward. Comet Hale-Bopp in 1997 showed similar behavior. Not alien propulsion, physics. Both natural objects. The trajectory, spectra, and comet-like properties suggest it's a lithified clastic fragment from an exoplanetary sedimentary basin. In other words, a rock and ice chunk from another planetary system's equivalent of our Kuiper belt. Hucke finds no evidence supporting artificial origin. Loeb himself hedges. In his blog post, he writes, "The simplest hypothesis is that 3 I-Atlas is a comet, and we are missing the spectral features of its gaseous coma because of its large distance from Earth." Yet he continues pushing 30 to 40% likelihood that the object does not have a fully natural origin, based on 7 anomalies, all of which have natural explanations confirmed by multiple observatories. Chris Lintott, Oxford astrophysicist, calls the alien suggestion absolute nonsense and an insult to the exciting work that is being done to understand this object. The scientific community studying 3 I-Atlas focuses on real questions. Where did it form? How old is it? Initial studies suggest between 3 and 14 billion years old, potentially older than our solar system. The carbon dioxide richness indicates formation beyond the carbon dioxide ice line of its parent star, possibly in a region with higher radiation exposure. The chemical composition tells you the star's planetary disk had different conditions than ours. Maybe lower metallicity, maybe a thicker disk. The trajectory traces back through the galaxy. One team traces it back 10 million years. The direction suggests it came from the thick disk stellar population, old stars with lower metal content, ancient remnants from when the galaxy was younger. This is cosmically significant. We're studying ice from another star system, material that formed billions of years ago, preserved in the cold of interstellar space, now passing through our neighborhood long enough for us to analyze it with the best telescopes ever built. An alien mothership sounds terrifying and clicks accumulate. The fabricated Michio Kaku quotes come from an interview months before 3 I-Atlas was even discovered. Someone edited a screenshot from February 2025, added fake captions, posted it in late September. Fact-checkers from Al Jazeera's Sanad agency investigate. They trace the image to an unrelated interview. Kaku never said anything about 3 I-Atlas, never suggested hostile intent. The whole thing is manufactured, but the damage spreads faster than the correction. By October, the narrative morphs. Some accounts claim the comet warning is itself a cover-up, that something else is coming, that governments use 3 I-Atlas as a distraction. The conspiracy eats itself. No amount of data from NASA, ESA, Hubble, Webb, Spherex, Swift, or ground-based observatories can compete with the viral engine. The truth requires reading orbital mechanics papers, understanding spectroscopy, trusting institutions, The lie requires watching a 30-second video with ominous music. But let's be clear about the numbers. 3. I-Atlas closest approach to Earth. December 19th, 2025. 1.797478 astronomical units. 268,898,938 kilometers. Almost 1,000 times the moon's distance. After that, it passes Venus November 3rd. 97 million kilometers. Jupiter March 16th, 2026. 54 million kilometers. Then it leaves permanently. The hyperbolic trajectory means it's not bound to the sun. It came from interstellar space. It will return to interstellar space. We get one shot to study it. TESS, the Transiting Exoplanet Survey Satellite, captures data. Pre-discovery images from TESS in May show cometary activity as early as May 7th, when 3 I-Atlas was 6.4 astronomical units from the sun, 2 months before discovery. The Swift Observatory monitors ultraviolet emission. SphereX continues spectroscopy. Europa Clipper, Lucy, Psyche, Parker, Solar Probe, Punch, ESA's SOHO, and JUICE spacecraft are all tasked to observe when geometry allows. The Perseverance and Curiosity rovers on Mars watch from the surface. Mars. Reconnaissance Orbiter from orbit. November 4th, ESA's Jupiter Icy Moons Explorer JUICE passes within 64 million kilometers and captures images. The data accumulates. Every observation confirms the same story. It's a comet, unusually carbon dioxide rich, incredibly fast, ancient, but natural. Water production rate, 6.6 kilograms per second. Coma diameter, up to 26,400 kilometers. Carbon dioxide gas coma radius, 348,000 kilometers. Dust tail length, 100,000 kilometers. Speed at discovery, 221,000 kilometers per hour. Speed at observation, 210,000 kilometers per hour. Closest approach to Earth, 270 million kilometers on July 21st. Perihelion distance, 210 million kilometers on October 30th. Age estimate, 3 to 14 billion years. Composition, carbon dioxide ice, water ice, carbon monoxide, carbonyl sulfide, dust, cyanide, nickel vapor. All of it fits comet models. None of it requires alien intervention. 3. I-Atlas passes behind the sun from Earth's perspective. Ground-based observation becomes impossible. The sun's glare blocks everything. Goes 19. Weather satellite can see objects down to magnitude 12. It captures the comet during conjunction. Faint but visible. Still behaving like a comet. October 29th, perihelion. The comet reaches its closest point to the sun, 1.4 astronomical units, 210 million kilometers, just inside Mars orbit, solar heating peaks. Outgassing should intensify. The possibility of outbursts exists. Comets sometimes eject large amounts of dust suddenly when volatile pockets sublimate rapidly. Fragmentation is possible. Borisov showed splitting. 3 I-Atlas could break up. As of October, no outbursts detected. Activity levels remain steady. But we won't know until observations resume in November when the comet emerges from behind the sun. Every rock and ice chunk in our system carries that formation signature. But 3. I-Atlas formed around a different star, possibly billions of years before our sun existed. The chemical composition reflects conditions in that distant protoplanetary disk. The carbon dioxide richness suggests the carbon dioxide ice line was prominent. The disk may have been colder, or the object formed farther from the star. The water content is low relative to carbon dioxide. Our solar system comets have the opposite ratio. This tells you the volatile distribution differed. Maybe the parent star had lower ultraviolet output. Maybe the disk had different dust opacity. Every molecule in 3 I-Atlas is a clue to planetary formation under different conditions. We've detected 3 in 8 years. Oumuamua in 2017, Borisov in 2019. 3 I-Atlas in 2025. Detection capabilities improved dramatically. The Vera Rubin Observatory will soon survey the entire visible sky every few nights. Capable of spotting objects down to magnitude 24.5. That's incredibly faint. We'll find more interstellar visitors, potentially dozens per year. Each one adds data points, different compositions, different ages, different origin regions in the galaxy. Over time, we'll map the diversity of exoplanetary systems by studying their ejected debris. This gives us a window we've never had before, directly into the composition of other solar systems. That's the story. Not alien invasion, scientific revolution. We're sampling the galaxy without leaving our neighborhood. Each one builds the alien narrative. He assigns a 30 to 40% probability of non-natural origin. Based on what? Anomalies that dissolve under scrutiny. He invokes black swan events, low probability but high impact. If there's even a small chance it's a Trojan horse, he argues, we should take defensive measures. Except probability requires evidence. You can't assign meaningful probability to a hypothesis with zero supporting data. That's not risk assessment. That's speculation dressed as caution. Other scientists push back hard. SETI researchers, people literally searching for extraterrestrial intelligence, find Loeb's claims damaging. They argue attention-grabbing, unsupported theories discredit the entire field, make it harder to do actual science. Penn State astronomer Jason Wright writes a detailed breakdown on his blog, points out the errors in Loeb's calculations, highlights the cherry-picking of data, notes that Loeb himself admits by far the most likely outcome will be that 3 I Atlas is a completely natural interstellar object, probably a comet. So why the media blitz pushing the alien angle? Wright concludes, Loeb's pattern of claiming things could be alien spacecraft without objective reason undermines serious technosignature research. Head of a project named after Galileo, the guy who challenged orthodoxy. It feeds a hero narrative, brave scientist willing to ask uncomfortable questions. Establishment scientists dismissing him because the alien hypothesis is taboo, except it's not taboo. Multiple researchers work on CD, technosignatures, biosignatures. The field is active. The issue isn't the hypothesis, it's claiming support where none exists. Extraordinary claims require extraordinary evidence. Loeb provides none. Just reinterpretations of ordinary observations and appeal to consequences. If I'm wrong, no big deal. If I'm right and we ignored it, disaster. That's not how science operates. Carbon-13 appears in the carbon dioxide. Distinguishing carbon-13 from carbon-12 is difficult because dust and other gases partially obscure the signal. But the detection suggests the parent star's planetary disk had similar isotopic ratios to ours, or different nucleosynthetic processes dominated. Either way, it's data. The water ice grains in the coma are smaller than 1 micrometer. The ice structure is likely amorphous, though crystalline water ice can't be ruled out. Amorphous ice forms at very low temperatures, below about 130 Kelvin. This supports formation in the cold outer regions of the planetary disk. The Swift Observatory suggests water ice grains sublimate beyond the nucleus, between 4,000 and 10,000 kilometers out. They're ejected by carbon dioxide and carbon monoxide outgassing, rather than water sublimation. The comet's activity driver is carbon dioxide, not water. Unusual but not unprecedented. Comet C 2016 R2 showed similar behavior. Ground-based images show elongation in the anti-solar direction. The cyanide coma on September 15th stretched 180,000 kilometers, elongated away from the sun. The dust tail visible in those images extended 50 arcseconds, about 100,000 kilometers. The sunward dust jet, the anti-tail, is shorter, caused by large dust grains pushed by internal activity. All of this maps to cometary physics. No anomalies, no mysteries requiring alien explanations. Just ice, dust, and gas behaving according to sublimation and radiation pressure. The velocity is high but explicable. Interstellar objects enter with hyperbolic excess velocity, the velocity they'd have at infinite distance from the sun. For 3 I Atlas, that's around 2 to 3 kilometers per second, depending on calculations. Not extraordinary for ejected objects. Gravitational simulations of planetary system formation predict ejection velocities in that range. Giant planets scattering smaller bodies fling them out at various speeds. Close encounters with other stars in dense stellar environments can also accelerate objects. The Milky Way's disk and thick disk populations have stars moving at different velocities. Thick disk stars have higher velocity dispersions. If 3 I Atlas came from a thick disk star, the relative velocity makes sense, no propulsion needed. Just Newtonian mechanics and 4 billion years of travel. Chemical age indicators are harder. The carbon dioxide richness and isotopic signatures give clues. The object hasn't been significantly altered by cosmic ray exposure or collisions. It's remarkably pristine. This suggests it spent most of its life in cold storage, ejected from its parent system billions of years ago, traveling through the low-density interstellar medium. No heating, no impacts, just drift, until gravity carried it into our solar system. 3, or I Atlas traveled possibly 10 million light years or more, depending on its origin point and wandering path through the galaxy. At interstellar velocities, that's billions of years in transit. It passed countless other stars, maybe skimmed close to a few. Gravity deflected its path each time. The trajectory we see now is the cumulative result of all those tugs. Tracing it back precisely is impossible, too many variables. But the general direction points to the galactic thick disk, a population of older stars with lower metallicity, stars that formed when the Milky Way was younger. When heavy element abundances were lower, their planetary disks reflected that composition. 3I Atlas is a fossil from that era. If Hubble's scheduling hadn't allowed quick follow-up, if Webb's observation window had closed, we'd have nothing. Just another dim object passing unnoticed. Instead, we have spectra, composition data, isotopic hints, age estimates, trajectory maps, a complete profile of an interstellar visitor. The third one, with more coming. Delivered to our telescopes for a few months before it vanishes forever, we learned the chemical signature of another planetary system. We confirmed carbon dioxide-rich comets exist beyond our solar system. We proved interstellar objects are detectable and analyzable with current technology. We expanded our understanding of planetary formation conditions across the galaxy. That's the legacy of 3I Atlas. Because correcting misinformation is harder than spreading it. A 30-second video warning of alien attack reaches more people than a peer-reviewed paper on spectroscopic analysis. The algorithm favors fear over facts. The social media ecosystem rewards sensationalism. And individuals willing to exploit that for attention gain platforms disproportionate to their credibility. That's fine for a rapid dissemination of preliminary ideas, but it's not a substitute for peer review. Other scientists read preprints, they find errors, they publish rebuttals, but the public doesn't follow that process. They see Harvard scientist publishes paper suggesting alien spacecraft and stop there. The nuance gets lost. The corrections don't trend. Observational data overwhelmingly supports this conclusion. The ESA echoes it. Every major observatory involved confirms it. Hubble, Webb, Sphere-X, Swift, VLT, Lowell, James Clerk, Maxwell Telescope, Rubin Observatory, Atlas, Zwicky Transient Facility. All the data points one direction: comet. Tom Statler's quote should be the headline. It looks like a comet. It does comet things. It very, very strongly resembles, in just about every way, the comets that we know. It's a comet. That's the scientific consensus. Not speculation, not maybe. Confirmed. The evidence is overwhelming. The composition matches comets. The behavior matches comets. The spectroscopy matches comets. The morphology matches comets. Every single observation aligns with natural cometary processes. 0 observations require alien technology to explain. Because humans are wired for pattern recognition and threat detection. A fast-moving object from outside the solar system triggers ancient instincts. Better to assume danger than miss a real threat. Social media amplifies that instinct. Algorithms prioritize engagement. Scary content gets engagement, accurate content gets scrolled past. The system selects for misinformation. Not intentionally, just structurally. The marketplace of ideas isn't efficient when attention is the currency and fear is the highest bid. Reading NASA's press releases, checking orbital data on JPL horizons, looking up spectroscopy papers, understanding what carbon dioxide to water ratios mean, trusting the expertise of planetary scientists who've spent careers studying comets. Most people don't have time. They see a headline. They share it. They move on. The misinformation spreads. The truth stays in technical papers behind jargon barriers. By 2030, it will leave the solar system entirely, back into interstellar space, continuing its billion-year journey through the galaxy. It doesn't care about our stories. It doesn't care about viral posts or scientific papers. It's ice and rock following gravity's path. We got a glimpse. We took measurements. We learned something. That's it. Test theories of planetary formation. 3. iAtlas will contribute to knowledge long after the alien spacecraft myth fades. Because data outlives hype. Evidence outlasts panic. The universe doesn't change to fit our narratives. We change our understanding to fit the universe. That's science. And the next interstellar object will arrive. Maybe next year, maybe next month. Detection capabilities improve constantly. Rubin Observatory comes online fully. More sky surveys launch. Sensitivity increases. We'll find more. Each one will spark the same cycle. Initial detection. Speculation. Data accumulation. Clarification. A subset will always claim alien origin, because the pattern is established. Oumuamua got the treatment. Borisov got less, but still some. 3. iAtlas got the full conspiracy package. Future objects will too. It's predictable. But underneath the noise, real science happens. Researchers worldwide collaborate. Data gets shared immediately. Follow-up observations coordinate across telescopes and spacecraft. Analysis pipelines run. Papers get drafted. Peer review occurs. Knowledge advances. The system works imperfectly. Slowly sometimes. But it works. We understand comets better now than before. 3I Atlas. We understand interstellar object demographics better. We understand carbon dioxide rich comets better. We understand spectroscopic analysis techniques better. Progress happened. Not because of the viral posts, despite them. Carbon dioxide, water ice, carbon monoxide, cyanide, nickel. Remember the images. Teardrop coma, dust tail, sunward jet. Remember the consensus. Every observatory confirms it's a comet. Remember Tom Statler. It looks like a comet. It does comet things. It's a comet. It doesn't go viral. But it's real. 3. Iatlas is a 4 billion-year-old chunk of ice from another star's planetary disk, traveling through this galaxy, passing through our solar system once, never to return. We studied it with the best instruments humanity ever built. We learned its composition. We estimated its age. We traced its path. We added it to the catalog of interstellar visitors. One more data point in the cosmic census. That's the story. Not collision course, not alien invasion, not dark forest hypothesis. Just ancient ice from a distant sun. Real. Documented. Understood. October 21st, 2025. 3. Iatlas moves behind the sun from Earth's view, hidden for a week, but tracked. Orbit known. Trajectory calculated. Goes 19 satellites watch from space. Instruments on Mars stand ready. When it emerges in November, telescopes will be waiting. More data will come. More papers will publish. More understanding will accrue. The scientific process continues regardless of social media panic. The universe doesn't pause for our confusion. It keeps moving. We either keep up or get left behind. The Mars orbiters captured 3 Iatlas during its closest approach, October 3rd. Trace gas orbiters' images show a fuzzy white dot, the coma visible despite the 30 million kilometer distance. Despite imaging systems designed for surface observation, they got the shot. Proof. Not smooth, not metallic, not structured, fuzzy, gas and dust. Exactly what a comet looks like from 30 million kilometers away. That image sits in ESA's archives. Anyone can see it. The evidence is public, accessible, undeniable. A comet, not a spacecraft. The case is closed before it even needed opening. But myths outlive facts when the myth is more interesting. 3. Iatlas will fade from headlines. The alien spacecraft narrative will attach to the next ambiguous object. The cycle repeats. Researchers will keep studying. Data will keep accumulating. Understanding will keep advancing. And the universe will keep sending visitors from beyond, each one a gift, a sample from distant systems. Free delivery courtesy of gravitational dynamics. We just have to look, measure, analyze, learn.